So today I want to talk about building AI copilots, which is probably on the mind of a lot of people that are building applications. Basically, how do you add a concept of an AI copilot to your application? I've got 15 minutes. If I wanted you to take away 3 things, it's why do you want to do this? What exactly is an AI copilot? Besides just another text chatbot. And how should you do it? And what are some sort of tips and tricks to once you get into production, what you should care about and sort of what you should be aware of. So first of all, I think we're entering a AI copilot era with respect to software. So you see this most prominently in many of the most dominant software applications, making AI copilots and adding AI copilots the dominant strategic initiative for this year and potentially next year. So you have something like Microsoft Office 365 Copilot, which is a huge initiative by Microsoft. And this, they've announced that they're going to generate something like $20 or $30 billion in incremental revenue. It's charged at $30 a seat. And if you imagine that penetrating their customer base, it's actually not just a little, hey, we got a little Clippy 2.0. It's something really that's going to be a big part of their business. Shopify is another example that's not yet out there in the market, but they're adding a sidekick to enable Shopify users to more easily do a number of tasks within that product. And Salesforce, that they're just at the Dreamforce conference, announced their sort of next generation Salesforce Einstein Copilot, again at a $50 upsell. So huge economic potential for these companies to build these AI assistants into their products. Now, okay, some of you may ask, is this Clippy 2.0? We all saw these things back in the day. And I would argue, and I think everybody should sort of keep this in mind, that AI seems to be a tipping point product. By that, I mean, if it's capable enough, it's absolutely amazing. And if it's not capable enough, it's darn annoying. And so I think if you read the room, what's going on here at this conference and what's going on in the industry, obviously the capabilities are going to get quite amazing over the next few years. And I think what we're going to see as a result is these AI copilots are going to infuse themselves into every single application. So what do these copilots look like? I think there's 3 dominant modalities if you're thinking about an AI copilot that you should be thinking about. The first is chat. This is sort of like the indisputable king and table stakes user interface. It allows you to interact, have follow-up questions. It's the interface that we all know from birth. And here's an example of, for instance, what that looks like within GitHub or the next generation GitHub Copilot. So not just tab complete, but actually allowing you to converse and take actions in a conversational way. The second modality that I think is very common is a command modality. So you can think about this like Copilot commands. So this is an example from a product called Hex, where they're doing text to SQL. They're not only doing text to SQL, but they fix, for instance, SQL errors. And this is like in the context of an application, can you automate a complicated workflow? Can you take something that's harder to debug, hard to take action, and automate that in a more one-shot versus multi-turn sort of way? And then the third style of a Copilot interaction, which I think we're just seeing the beginnings of, is really this autonomous agent pattern. And this is where an AI Copilot can actually react to events and fully automate workflows. And so in this case, this is again from GitHub Copilot, the next generation of what they're announcing. Which is, on your pull request, as soon as you open that pull request, you get a detailed summary, you get code review, you get potentially you even open an issue and you get a pull request for free. These types of proactive alerts and proactive capabilities of copilots are I think are the next sort of next generation. So how do users benefit? First, these AI copilots answer questions, right? So users don't know everything about the products. They don't know everything about the particular domain. So just answering basic question itself is a huge unlock. The second one is they assist, so they allow you to work more efficiently, especially for complicated sort of tasks. They allow you to quickly generate that output. So that could be text to SQL. If you look at what Vercel just did with their v0.dev, it's like text to UI, front-end UI. And these are sort of capabilities where these AI copilots are sitting there right next to you, understand your application and your domain, and allow you to move quicker. The final one, which is the frontier, is really when they're talking about automation. And as the capabilities of these LLMs get better, as the ability to attach LLMs to APIs, for those LLMs to be attached to planning and reasoning systems where you're taking multiple steps of actions, I think this latter category around automation is going to be increasingly common, even if it's exposed through a command or through a chat interface. Okay, so that's sort of the the why and the what. how do we build these systems? So I'm one of the founders of a startup called Continual. We're basically building an AI Copilot platform for embedded applications where want to embed an AI Copilot. And so we've sort of seen a number of companies try to implement this, and the struggles and the struggles of doing that, or what are the core components, and sort of what do you have to be aware of. So the nice thing I would say is over the last year, there's an emerging standardization, if you will, of the architecture of what a Copilot system looks like. And so there's kind of a convergence in what are the building blocks for if you want to build an AI Copilot, how do you sort of build that up from the foundations of your existing application? So at the bottom, you have your application. That consists really of two things. It consists of your APIs, right? That could be your REST API, your GraphQL API, your gRPC API. That's the interface both for the LLM or the AI to understand what your application knows and actually to take action within the context of your particular application. The second one is data sources. And these could be behind your APIs in some cases, but in many cases they're more sort of nebulous things that you need to be able to search more fluidly. So they could be, for instance, be your knowledge base, your documentation, the domain that you're operating in, if you're, for instance, in a legal domain or an electrical design domain. They could be user data that you want to index in a more fine-grained way that may not be today exposed through your APIs in the right ways. So on top of your application and your application APIs and your data sources, there's really the heart, the brain of the Copilot system. And there's many different ways to implement this technically. You can implement this, I talked to some folks at LinkedIn who are implementing it on top of Ray. Obviously there's a lot of people that are implementing things on top of LangChain. And then there's Continual, which is what we're working on, is really an all-in-one platform that's laser focused on enabling the full life cycle of a production AI Copilot. So there's a number of components to this. At the top level, there's task orchestration. And what I mean by this is when a user issues a request, unlike ChatGPT, right, which basically the LLM is the only thing that responds pretty much, although plugins change that a little bit. Within the context of a Copilot, you really, really need to ground the answer of your Copilot, of your AI assistant, in the domain of your application. Namely, it needs to deeply understand your application. That could be, for instance, your product documentation or your knowledge base. And the data that's sitting behind your APIs, the system of record for your business, your CRM or whatever that is that you're adding a Copilot to. In addition to being able to plan, okay, given a user request, how do I figure out what the user wants, what information I need to be able to answer the user's question, and then what actions can I take within the system, and then potentially what should I show back to the user, and do I need to ask the user for additional information, or should I ask the user to confirm an action that I'm proposing? There's a whole complex reasoning and planning process that happens. So at that top level, there's a reasoning and planning process, and I'll talk a little bit about the different ways to do that in a second. But behind that, what is it planning over? It's typically planning over calls to a few different subsystems. The first and most obvious is the models themselves, the large language models. And those could be things from OpenAI and major external providers, or they could be internal models, for instance, like Llama 2 and open source models that maybe you fine-tuned for particular problems within your domain. The second one is what we call data sets, but you could call it indexes or vector store. It's basically knowledge that you're encoding into a more semantic representation that you can look up and enrich the context of the LLM, because the LLM may not have been tuned on it. And this is often the case. These large language models, even GPT-4, really are pretty naive about most applications. They don't understand the incredible subtlety of most applications or most niche domains. And that's especially true if it's an internal application, right? So if it's a public application, maybe they've read the public docs, but it's probably out of date. And then it's an internal application, they probably don't have any clue about what that application is. So you need to ground it in the domain of your application. The second one is plugins or extensions. This is really how do you call out to your external system? How do you call out to your APIs? And the final one I would say is workflows. You could maybe subsume it here a little bit, but this is often there are specific ideas with specific workflows or user journeys or tasks that your user needs to complete, which you want to guide, which you want to say, hey, I don't just want a wild reasoning process to happen. I want to guide through it. So those are, I would say, the four kind of building blocks that the task orchestrator needs to deal with. And then below that, which is critical, both pre-production and post-production, is these three core ideas of evaluation, how is this thing doing, monitoring, like what's going on, and feedback. Hey, how do you get feedback both from your end users and from your internal team where you say, okay, let's train this system to actually do a great job. On top of this engine can potentially power all of those different user experiences that we just chatted about. So you have Copilot chat, you have your front end of your application, you have the sidebar conversational chat experience in many cases. You have commands that are in line with particular like hey, can write this job posting listing right in your HRIS system. Or automations where you're reacting to events and automating workflows on behalf of that user. Often that can be done through the exact same Copilot system, right? Okay, so what are the top challenges in production, right? That looks great from a pseudo-architecture type of perspective, but what are the actual challenges? And there are a lot. I would say there's primarily three. So one is cost. That is something that we got to keep, there's always an ROI calculation. These models are not free. The second is capability, namely what can you actually achieve? And the third is latency. And from my experience, these two are by far the most important. Capability plus latency. The quality of your Copilot is essentially capability minus latency. The user experience is how much can this achieve in what period of time, and does that feel delightful or does it feel miserable? And that line is very fine, and so that's why I would say you got to be laser focused on it. So what are some tips to address these with a few minutes at a very high level? So let's talk first about latency. At a sort of simple level, sort of level one, what can you do to improve latency if you're building a Copilot? First of all, stream responses, right? You've all seen this with ChatGPT. It makes a huge difference when that first token comes quickly. The second one, which is a little bit related, is try to respond concisely. If it gets too verbose, that's going to take a lot of time and it gets sort of annoying. And that that also applies to internal monologue and reasoning. If you do too much chain of thought reasoning, you've gotten excited by step and chain of thought to get performance, that does lead to a latency trade-off. And so you want to say, how do I get capability with low latency? Using smaller models is another one. GPT 3.5, Claude instance, Llama 2, 7 billion, super fast compared to, for instance, GPT-4. So you've got to trade the quality versus the latency of those two things. And then the other one, which is very important, is do cool things in the UI. Mask the retrieval augmentation, which is RAG here, and plug in latency behind progress updates and UI elements. Then there are some things that are more advanced. You can do, so one is retrieval is critical. There's different ways to do retrieval, and I think one big lesson that we've learned is try to do retrieval up front super fast. It's possible to do it super fast. There's a lot of fun ideas around hypothetical document embeddings, generating queries from the LLM, but as soon as you introduce an LLM call right up front, that's latency before the first token to respond. And so try to make your retrieval system as fast as humanly possible, and that will help a lot. If possible, also, if you are taking actions, try to do as much planning in one shot so you can plan and then start executing, right? If every time you plan an action, you have to wait for a while, that can be really hurt the user experience. And so there's things like React and Reflexion, which are, seem great, but again, they often, although they improve performance and they say we improve GPT's performance by X, they introduce significant latency due to the way they reason. They often reflect over their process and what they're observing, first write out a bunch of tokens to reflect, and then respond. And every time you do that, that is latency, which again causes a trade-off with respect to the user experience. Finally, if you're really advanced, you can consider fine-tuning for planning and for task execution. So separating the actual planning models from the actual response models. And that actually can lead to very good performance and much, much faster planning process. There's an open source example of this called Gorilla. So with 1 minute left, I want to talk about capability. What can you do on capability? So start simple. That's an obvious one. Be honest with yourself about the capability and latency of your prototypes. So don't delude yourself into thinking that you actually have good capability or good latency. And then third, carefully design your plugin APIs. Limit the number of requests or the number of parameters. Limit the response, and expose search as a key concept, because users don't know user IDs. They only know users' names. There's a ton here on quality that you can do. It all starts with evaluation, so definitely start with evaluation up front. These are harder things to do. Carefully tuning your RAG system. There's lots of different ways to do that. Multiple embeddings, re-ranking, smart chunking. That can significantly improve the way you look up external information. And then train custom models for unique capabilities. That really can often be a night or day difference for your particular application. And then this final one, if you want to learn more about it, come over to us. We're over at the Continual booth over there. I'm happy to talk about self-exploration and training for these types of copilots. Finally, last slide, just be ambitious if you're doing a copilot. AI copilots can, and I would argue must, be amazing to really see their true potential. So if you dismiss them and they're not good enough in a moment, try to be more ambitious, try to make it amazing. It's definitely coming, and would be happy to chat with anybody about that. Thanks.